Hello everyone. Today we will be talking about our final year project, which is titled Type 2 Diabetes Individualistic Treatment Line Suggestion Using Artificial Neural Network. So, what that means in simple terms is that we try to achieve to build a project to serve as a helping hand to diabetologists rather than replacing them. The goal of our project is to assist doctors in identifying the accurate treatment line for their patients. So presently in the world, there are around 11 drug types which are used to treat type 2 diabetes patients. Out of these, 7 are popularly used, and our project basically classifies patients according to their characteristics into these 7 classes, which are the drugs. So, namely, these drug types include DPP-4, metformin, SGLT2, and so on. So, up till now, till date, what methodology diabetologists use is that they use the years of practice and experience and a trial and error method basically to identify the treatment line suitable for their patient. But our project aims at rapidly providing the doctor with an extremely accurate solution to this problem. They don't have to do any guesswork. They will be provided with a suggestion about a treatment line which will be most suitable for their patient. This will be an individualistic treatment line, that is, it will vary from patient to patient depending on that particular patient's characteristics. So these characteristics or attributes are namely the patient's age, weight type, their associated diseases, and so on. So, doctors often use ADA guidelines. They have to follow these guidelines, which is laid down by the American Diabetes Association. And these guidelines, we have also integrated them into our project, and we've made sure we followed all these protocols. Uh, so, why have we used machine learning and basically ANN? Is because of its accuracy level, and it's very suitable for multi-class classification. Um, so, after this problem analysis, we went ahead into the second phase of our project implementation, that is data set. So there wasn't any particular data set that was pre-made or available on any site or on the UCI repository. So we had to collect data, which was real-time patient records. We approached a diabetologist and we got access to hundreds and thousands of his patient records, which patients he had treated over his years of practice. And we converted this raw data into a suitable data set. We identified the input attributes that will be required for our system. These input attributes were included in our data set. They are namely the patient's age, weight type, whether they have a kidney disease or any associated disease like heart ailments, or even included the financial situations into our data set. And this is a label data set, so it has 7 labels or classes, which are the output attributes. These are namely the 7 drug types, which were included in the data set, which is metformin, SGLT2, GLP-1, and so on. So currently our data set holds around 2,400 records, and this data set took quite some time to be made, but it was a necessary step for us to take. And after problem analysis and data set collection, we went on to perfect our architectural diagram and basically a system architecture. And this will be explained in detail by my friend Prachi.
Okay, so here the user is a doctor, and he'll operate this system on an application, which will be in a GUI form. Then first, doctor will have his credentials, login credentials. Then he'll log in and enter the patient data. So when in basically the input is the patient's history, that are weight, height, and uh, other things, and this data will be pre-processed, and it will be data cleaning and data normalization and standardization. So we have lots of data, a bulk of data. So we need a cleaning of it to be more sure. So this will be a patient database. There is drug data. In that we have seven medicines, and based on that medicines, they have their individualistic working functions. Based on that, the patient will be given a suitable drug to his suitable history. That will be trained by a ANN model. We have choose ANN model because it is more accurate, and and it is more useful for the doctor to be precise in giving the drug to that patient. Then the ANN will process its output, and it will be given to a GUI system, and it will display its summary to the doctor, and rest the backend process will be explained by my fellow member Atharva Dharne.
Okay. Hello, everyone. So we have used Python programming language for the backend programming of our ANN. Python is an open source language, and with all the available modules, easily available or inbuilt modules like NumPy, Keras, etc., it's quite easy to implement a large amount of large layered or multi-layered neural network, which is quite hard to program in any other language. So all the inbuilt libraries we have used are TensorFlow, Keras, TensorFlow library, Keras, OpenXYL, etc. Matplot library for the development or showing graph as a final output. So basically our ANN or the multi-layered ANN model is a sequential model, as you can see here, and it has multiple layers with almost five hidden layers, and the final output layer with 7 neurons. This is because that we have 7 classes of treatment or drug line treatment or medicine line treatments in which our patient will be classified in one of those 7 classes. In the hidden layer, we have used the activation function ReLU because as the patient data will be is a binary data as previously seen, it will be in the form of 0 or 1, and no negative data is there. So as a probabilistic output, we'll never get a negative value. So ReLU function will clip off all the negative values, and it will give the values only between 0 to 1. So that's why we have used it. We have used, for the final layer, we have used softmax activation function. It is best for the multi-class classification. Otherwise, we would have used, if only 2 outputs would have there, we would have used sigmoid function. But due to multi-class classification, we have used softmax function. And there it is. All the number of neurons in each hidden layer is achieved by tweaking and trial and error method, which can give maximum accuracy. And our input layer consists of 25 neurons, which are our 25 attributes, patient attributes, will each neuron representing one attribute, and it will pass to the next hidden layer. So here during the command, we have used categorical cross entropy function for calculating the loss value, as it is a multi-class classification again, and accuracy as the matrix. So as you can see here, I've already run one instance of the program using 67 epochs. Our final accuracy which we achieved is 92.70%, and our output is in the form of 2 dictionaries, one with the probabilistic value of each class classification and the other with its name. So the model suggested medicine aglucoacidase with 92% accuracy. And the final, and also this is the numeric or subjective or word output. Also the graphical output is in the form of graph, which we can see here. The probability or the medicine with the highest probability is okay, wait. Medicine with the highest probability is displayed using the graph, so the doctor can easily figure out which medicine to use. Even if 2 medicines have close probabilities or close displays on the graph, the doctor can check the accuracy value here, which we give based on each medicine, and make his decision. But as this is the background or technical part of the project, which the doctor has no need to know, and for the ease of for the ease of use of the doctor, this project will be implemented. This project will be implemented using a GUI, which will be better explained by my partner Neha.
Hello. Uh, so I'll be explaining the GUI which we have. Yeah. So basically, first of all, a doctor has to have a proper login, because not everyone can access the information regarding patients, as it can have some of the critical information. Uh, just a minute. This is how. Here we get the patient name and patient ID, after which we can see the data of the patients after clicking on the respective ID. The details considered, include the suggested medicine and the graph. In many cases, there are two suggestions which are which have really similar probability. So the doctor can get an idea about the possibility of a patient getting a medicine by seeing the graph. After this, we also have the feature of adding a new patient. When a new patient comes here, we include all the data set, all the attributes from the data set, and we have just given check boxes, because generally most of the attributes have the value 0. That is, most of the attributes are absent in the patients. That's why only the problematic attributes have to be selected. And the HbA1c level is the level of the hemoglobin which the doctor requires, and which we will include in our prediction. And from here, the patient is added in the database, and we can again see the details of that patient by clicking on its name, and we can log out. So basically, the features of this GUI is that we have used Python at the back end, as Python is the most suitable language for. We have used Python at the back end as it is the most suitable language uh, for machine learning. So we thought that we could integrate the machine learning part with the GUI part. So I used the PySimple GUI library, which had many layouting by default layout elements such as buttons, checkboxes, containers, etc., which made it really easy for verifying all the aspects and integrating the machine learning part of the project with the database and the GUI part. Moreover, for accessing the database, I use OpenPyXL library and also pandas, because the data frames are given as the input to the machine learning. To the trained model. The data frame is of the patients that are entered by the doctor, and it is given as a in the form of input to the artificial neural network, from which we get the output, which is displayed in the form of graph, and the details are seen by the doctor at the front end. Uh, Other features of this GUI will be that it is quite intuitive, and doctors can easily access the information of their old patients as well as create new patients in no time. And moreover, PySimple GUI is a library under development, so it didn't have many newly developed features, but we could implement some of the basic and useful features using it, which made it really easy for us to develop it with the Python, using machine learning and Python. Um,
And overall I feel this was the whole project which can be uh, developed further for uh, using not only for diabetes but also health other healthcare applications. And the data set which we have now is quite rudimentary, but considering the vast amount of people, the vast amount of data set created by the people all over the world, or whenever if we get ever an access to a centralized database, we would have a model which can be implemented easily, and we will have a system that can really help the doctors to work on it really efficiently. Thank you.